Hey there, welcome to episode 6 of Brewing Better Java. I'm Plese with Azul. Now, as a part of these episodes, we talk about all things Java or different conversations we're hearing from the global Java community. Now, if you're a Java shop, or if you build or architect mission critical or business critical Java applications, I think you're going to love the conversation that we're going to have today. We're going to break down the 4 common misconceptions or myths that we see when talking about how to get more performance from your Java applications. We're also going to tackle an emerging topic around architecting your applications with frugality in mind. And we're going to dig into cloud cost optimization strategies specifically for your Java estate. So with me for this conversation is John Ceccarelli. He's Senior Director of Product Management here at Azul. Welcome, John.
Thank you. Great to be here again.
Awesome. So I know, John, as a part of your role here at Azul, you work with global Java developers and architects to benchmark exactly how fast they can get their code speed, the code to go in production environments. And I know that you've been working with cloud architects recently on modernizing their architectures to improve performance and perhaps keep CPU usage and levels in checks, but ultimately improving the total cost of ownership for their architecture. So we're going to tap into that wisdom and some of those conversations you've had with the market. So let's get right to it. So John, let's take a look at our first myth here, common misconceptions. Now, there's a lot of different runtimes or distributions out there in the market, and there's some choice of what JVMs that you can use to build your applications. Here at Azul, we have our own distributions. But, how you choose really matters because different Java workloads may have different challenges associated with them. So let's go ahead and break this down, John. Are all Java runtimes created equal in your mind?
Right. Well, as you said, there's more official distributions of OpenJDK to choose from than ever in the market these days. But most people consider that to be just different variations on the same thing, right? So, Java is just Java, right? And while it's true that most of the Java versions like Oracle, Temarin, Corretto, or Azul Zulu are just vanilla copies of the OpenJDK. Their whole point is to be exactly the same, to maximize that ability to make sure that if you run something locally on Temarin and then you run it on Corretto on AWS, it's going to behave exactly the same, 100% exactly the same. There are other distributions there are other JVMs that Java runtimes that are actually different and that try to differentiate themselves in performance and in the cost of running applications on them, how the performance characteristics and so forth. And of course, the foremost of these is Azul's Zing JVM, which is part of Platform Prime, which is really built from the ground up with today's cloud-centric workloads in mind, and built to deliver better performance and deliver lower cost of ownership, lower cloud costs for running your Java workloads.
Okay. All right. So that's kind of sets the table and sets us up for our next myth. So this one I think is really interesting. So that there's a misconception out there, does your choice of Java runtime impact your cloud bill? And let me provide a little bit more color around that too, is that for companies with a digital operating model, right, cloud spend is typically number 2 behind labor on their balance sheets. Right. And the reality is that Java is still a top programming language for many companies today. It's out there. But what's not really known is that if you can run it faster, you can actually curb your cloud compute spend, right? So, I think this is a big misconception. So John, why don't you break that down for us?
Right. So, cloud financials has become, cloud financials, FinOps, it has a lot of different names depending on who's talking, but just integrating cost as a non-functional requirement into how you architect your Java has become huge, and it has to become huge for people because cloud, due to its elastic nature, due to its self-serve nature, and so forth, people have seen their cloud bills really, really explode. And so, as a matter of fact, this was a huge focus of reInvent last year with the Frugal Architect Manifesto being published, which is really talking about how, as architects, we really need to bring cost in and build the cost considerations around cost into everything we do when we architect. And so yeah, it's when people think about architecting for cost, right? So people think about how do I get the same or better user experience from my Java estate while spending less money. People typically think about like the architecture of their design. How can I split these things up? People think about your typical FinOps things about, like, is my storage running on the most cost-effective layer? Am I right sizing my instances? Am I, can I move these things off to something like serverless, and so forth, right? So there's a lot of that, and then there's also just in your own code, right? If you have, some really inefficient queries in your code or so forth, those things are going to impact how much CPU it takes to run those queries. So people, and these are good things to think about, right? These are definitely things to think about. But another tool in the toolbox that people don't really think about is what Java runtime you're running your Java on. Because at a certain point, there's only so much that you can squeeze out, and you really need to, if you're building a culture of continuous improvement, which is one of the main points in the frugal market, the frugal architect manifesto, right? Which is to continuously be improving and to think outside the box. Another big point there, right? Then you're going to need to bring all these tools in. And one of the very valuable tools you can have is a JVM that is architected to run your code faster. The faster you run your code, the more requests each instance can handle, the less instances you need altogether to deliver your functionality. So yeah, I think the Java runtime can impact your cloud bill. We have customers who we've saved millions of dollars just switching their apps from vanilla OpenJDK onto the Zoom JVM, and yeah, it's probably the best kept secret in the computer industry today.
Yeah, that's a really good point. And I was looking again at the 2024 State of FinOps report from the FinOps Foundation. And, there's a lot of interest, and one of the number one priorities is reducing cloud waste, right? And maximizing cloud value. And I think FinOps practitioners are getting closer and closer to doing that. And the thing about Azul Zing in our JVM is that there's no, you don't have to recompile your code. There's no code changes, right? So if you're going to introduce this to your architecture, and I know for many of our customers, especially the cloud centers excellences, they are standardizing and mandating, right, that as a part of their architecture, they use a high performance JVM, right? And that's the thing. And I think that's a real good way to really hit the frugality targets and hit the targets that they're getting from their FinOps teams.
Exactly. Yep.
Okay. All right. Let's move on here. Let's look at our third myth here. So what are the common Java performance problems in the cloud? So John, I know you've seen a lot in your role. Yeah. So let's dig into this juicy topic here.
Right. So, I mean, when you say performance, people typically think just about speed, about latency, right? And so you have people who are trying to resolve, your common, like, all my stuff's running slow. Geez, why is this thing running so slow? Right. Those are actually, frankly, the simplest problems to resolve. And usually it's somewhere in your code. Usually it's something wrong in your code. You refactor things and so forth. And you get to a thing where, like, hey, wow, now that's a lot better. Most of my code is running fast. But I've got this, these outliers. I've got these, like, 1% not even 1%, 0.1% or 0.01% of my transactions suddenly are taking 5, 6, 10 times as long as the rest of them. And 0.01% might not sound like a lot, but it really is, especially when you think about today's modern architectures where one process is really a series of calls, whether those are step functions and lambdas, or whether those are microservices chained together to call each other that are running on some other infrastructure, right? If you've got a chain of 7, 8, 9 microservice calls, right? And those calls are, and any one of those calls being slow slows down the entire end user flow, right? And then you've got that chain being called hundreds of thousands of times, millions of times. Then a 0.01% in latency outlier can really affect your code. And so that's where Azul has been working for years now. We were the first to bring pauseless garbage collection to the market and have that available for all Java versions. But one of the things we do is reduce that and really get rid of those outliers so that you have nice steady execution all the way across. And this, to bring it back to cloud costs, which is what we were talking about, this really helps drive down cloud costs, because what happens if you have these outliers? What do people typically do? They over provision. They throw more servers at it, right? And so yeah, when you think about performance, like I said, a lot of people think about speed, but I think there are much more interesting aspects of performance, and especially some that are especially problematic with Java. And another aspect of performance that I think is really big and really influences cloud costs is time to speed, is the warm up. So not just how fast you go when you reach top speed, but Java has this warm up process that it has to go through every time you start a new JVM. And that process can, your performance can just straight up suck at the beginning of getting your JVM going. And so what happens is you become afraid to start machines up. You tend to want to leave your machines on all the time. Well, how does this impact cost? Well, the fact is that the whole reason why cloud is a more a more economical way to run your apps is the elastic nature. You can turn stuff on when you need it and turn it off when you don't need it, right? If you are just provisioning stuff and leaving it on even when it's not needed, you're not getting the most out of cloud, right? But that Java warm-up problem does cause people to say, ugh, with Java, I better just leave it on all the time. And we have lots of innovative solutions to get you to full speed as quickly as possible, so you can really embrace that cloud elasticity, reactive auto scaling, whether it's reactive auto scaling or so forth, to really be able to embrace that cloud elasticity and save the most amount of money you can using that cloud operational model.
Right. Yeah. I remember one of the use cases you and I were talking about was, at the warm up is, with the profiles needed to understand when the JVM wakes up, it needs to understand what it needs to do. Right.
Right.
Right. And I think in some of our deployments for our customers, we've actually given those JVMs and fleets of JVMs long-term memory. Right. So when they wake up, they have a profile available to them. So they already know what they have to do. Right. And that is how we went about solving this problem. So I think there was one use case, I think it was one of our e-commerce customers. Can you talk a little bit more about how they're using that capability?
Right. Well, this is what I mean about a JVM that's built from the ground up to fit into these cloud use cases, right? Or this new cloud way of deployment. The JVM whole operating model was designed a long time ago. Where a computer was a computer. It was a rack sitting somewhere. It didn't have, it had to be completely self-sufficient. And so really, we designed our JVM the Zing JVM to be aware not only of what it's doing, but to be aware of what other JVMs in the fleet are doing,
Right.
And so if you've run a program many times, if you have other JVMs that are running the program, we can slurp all that information into one central place, which we call Optimizer Hub,
Yep.
so that we know that for that typical application, what things do I need to do to get that thing to the maximum possible speed as quickly as possible. And that profile information we gather in our central hub, and then as new JVMs start up, we can direct those JVMs to get faster, quicker. Yeah.
Right. That's really
And yeah, and we're using this at some very large companies on their most critical workloads. Yeah.
good.
And
Yeah.
again, driving millions of dollars of savings doing it, and driving better customer experience at the same time.
That's good. That's good. That brings us to our last myth here. Are you running out of ways to draw down committed cloud spend? So let me tee this up here. So AWS and Google offer enterprise discount programs, or EDPs, because the world needs more acronyms. So this is where companies opt to prepay or commit to a 3-year or 5-year amount of spend and consumption with the hyperscalers. And FinOps teams are becoming better at actually managing that committed spend. Right. But I think you see this, John. At no time in history has a Java developer had more indirect buying power on their cloud spend, because they have this disposable infrastructure mindset. Right. So let's break down this myth, because I think that using the programming language in Java is emerging as another tool in the toolbox, which we've talked about, to really leverage that committed spend. What are your thoughts there?
Well, so the question of committed spend is an interesting one. And so companies are committing to very large commitments in order to secure the larger discounts from the cloud vendors. It's true. And so the more they spend with their cloud vendor, the bigger discount they get. So you're seeing more and more companies wanting to purchase not just the compute power, the storage, the networking, through the marketplace on the cloud providers, but they want to actually also purchase the software that runs on that infrastructure through there. They want to have one central point of purchasing that they're running everything through, so that they can get the more money they get through there, the higher discount they're going to get. And so yeah, that's a very compelling value prop for a lot of our customers, and that's why Azul does offer all of our offerings through the AWS and the Google and the GCP marketplaces. So yeah, you can purchase not just your compute instances, but purchase your licenses for the Azul software that runs on those through there. And drive your usage up, and if maybe you overcommitted, you can burn down some of that committed spend, and get the best possible discount
Possible. Yeah. Okay. That's a key one. That's a key one. So, okay, I'm going to go ahead and wrap this up here. So, thank you so much for joining us today. If John and I have inspired you in any way around, if you want to learn more about a high performance JVM and Java runtime, please reach out to us. Please do scan the QR codes there. So if you want to download Platform Prime for free today to test it, to see how fast you can get your code to go, we offer the QR code for you to do that here. And there's also a QR code to learn more about the myths and some of the CCO and cloud cost optimization best practices that John and I talked about today. So also, please join us for episode 7 on August 16th, Brewing Better Java. We're going to be focusing on Java 17. Stay and pay, or save and go will be the topic of that episode. So thank you so much for joining us today, and have a great rest of your day. Thank you.